In this lesson, we're going to look at how to solve trig equations. So previous to this, we learned how to evaluate trig expressions. So to how to find sine of 30 degrees or sine of 150 degrees. Now we're going to look at how to go backwards. So just a couple reminders here, then we'll fill in some notes on actually how to do this. So off to the side here, I'm just going to write some reminders from our previous trig units. So our special right triangles are going to be huge and very important. So remember we have our 30, 60, 90 right triangle. So if this is my 30, this is my 60. So across from the 30-degree angle is the shortest side, that's 1. Across from the 60 is the middle length, so that's the root 3. And then across from the 90, or the hypotenuse, is 2. And any multiples of this would also work. We have our 45, 45, 90 right triangle, so our isosceles right triangle. Let me try to redraw this so that looks more isosceles. So this is our 45, 45, 90. So this is 1, 1, and then root 2 to the hypotenuse. And then just some quick conversion reminders. So 30 degrees is the same thing as saying pi over 6 radians. 45 degrees is the same thing as pi over 4 radians. And 60 degrees is the same thing as pi over 3 radians. So a quick way to kind of remember these is think about pi radians as 180 degrees. So 180 divided by 6 gives me the 30. 180 divided by 4 gives me 45. 180 divided by 3 gives me the 60. And then another reminder too, our unit circle. So if we think about our unit circle, remember this has a radius of 1, so none of these triangles here would be adjusted for the unit circle. You'd have to divide by the hypotenuse to get to the unit circle. But if I'm looking at the unit circle, what I really want to look at are the 4 key points here. So these 4 key points, so 1, 0, 0, 1, -1, 0, and 0, -1. These represent our 0 degrees, our 90 degrees, 180, 270, and then back to 360. These represent the cosine and sine. Remember, the cosine is what comes first, so it's cosine theta, comma sine of theta. So cosine of 0 degrees would be 1, sine of 0 degrees would be 0, is what this is saying. Remember that you can also think about these in radians. So this would be 0 radians, pi over 2 radians, pi radians, 3 pi over 2, and then back to 2 pi radians. So those are all ways that we use, or those are all the methods that we use to evaluate a trig expression. Now we're going to look at solving. So in order to solve, the steps that you want to follow, the first thing you always want to do is you want to isolate your trig function. Similar to other types of functions or equations that we've solved, we always want to isolate, in this case, our trig function. And then once you have your trig function by itself, then what you're going to want to do is you're going to want to determine the reference angles that solve the equation. So I'm just going to say determine reference angles that satisfy equation. And that's where we're really going to be using our unit circle and our special right triangles to help us with that. And then what we also have to consider is all angles around the unit circle. So not just the acute angles or the angles in the first quadrant, we have to consider all possibilities. So what we're going to do is we're going to then find all solutions by finding the location of angles using the quadrants, which quadrants are positive versus negative. So I'm going to write the A STC. Remember, this stands for um, all students take calculus is the acronym we use to remember it. But what it really means is it tells us where each of these trig functions are positive. So all trig functions are positive in the first quadrant. All sine and its reciprocal, so cosecant, are positive in the second quadrant. Tan and cotan would be positive down in the third quadrant. And then the fourth quadrant, cosine and secant are positive. Every other functions in those quadrants would be negative, is what it's saying. So that's going to help us determine the location. So let's use these steps and actually try solving some equations. So for the first example, solve algebraically for all exact values of theta over the domain. So notice that my domain here is 0 degrees to 360 degrees, not including 360. That means our answers are going to be in degrees. Some of the other problems are going to be in radians. So it's important to look at that and make note of that when you're solving. So my first step here is to get the trig function by itself. So let's solve for cosine. So what I need to do is that let's isolate it. So I'm going to go ahead and just subtract this 3 cosine over. So kind of almost think of this as like if this said x equals 3x plus 1, we'll get x by itself. That's exactly what I'm doing here. So I'm getting cosine by itself. So this is going to be 1 cosine minus 3 cosine, so negative 2 cosine theta. And you don't need to show this step. I'm just doing it so you can see how I solved it. Equals 1. Now I'm going to divide both sides by negative 2 to get cosine by itself. So I have cosine theta equals negative 1/2. Now that I've isolated this, I need to figure out, well, what reference angle satisfies this equation? So basically, what do I take cosine of and get out negative 1/2? So the easiest way to think about this is to think about your 4 quadrants here. So first of all, let's think about where these would be located. So all students take calculus. We're looking at a negative cosine value. So we know it's not going to be in quadrants 1 or 4 because that's where cosine's positive. So we're looking at quadrants 2 and 3. And now if we think about drawing in our reference triangle here, so I know I'm going to have 2 reference triangles. You want to think about, well, cosine of theta is going to be 1 over 2, so, or negative 1 over 2, so that's the adjacent over the hypotenuse. So if these are my angles, remember your angles are always measured from the x-axis. So if these are the angles I'm looking at, adjacent would be this side right here, so that's the negative 1, and then the hypotenuse is going to be 2. Same thing down in this triangle, adjacent over hypotenuse. And what special right triangle did this come from? Well, look right here, we have our 1 root 3, 2. So this tells us that this is actually our 30, 60, 90. So this is going to be root 3. This would have to be negative root 3 because it's going down. And then remember, hypotenuses are always positive. That's why I put the negative 1 here going to the left. So now think about, well, what reference angle is that? Well, across from the root 3 is going to be your 60-degree reference angle. So this is a 60-degree reference angle. But that's actually not the answer to the equation, because if you find cosine of 60 degrees, you're actually going to get a positive 1/2. We want to know, well, what is the angle that has a reference angle of 60 degrees in the second quadrant? Well, that's going to be this entire angle here. So that's going to be 180 minus 60. So that's going to be 120. So now I'm kind of on step 3 here. I'm finding all of these angles. So this is going to be 120. And then the other solution that would work is if we use this angle down in the third quadrant that has a reference angle of 60. So that's going to be 180 degrees plus 60. So that's going to be 240. So that's my other solution. So both of those would end up giving us negative 1/2 when you take cosine of them. So that's the exact process that we're going to go through. I'm going to make it a little note here too that my reference angle was equal to 60. Oops. That's the first thing I found. And then I did my location. So that's just kind of, showing your work. You don't necessarily have to write that, but just to kind of show you my thought process. So for number 2, now we're going to solve algebraically over the domain of 0 to 2 pi radians. So now we're in radians. So now when we go to find our reference angles, we're going to state them in radians. Otherwise, the process is pretty much the same thing. So our first step here is let's get tan by itself. So I'm going to bring the 5 tan theta over to the other side. So it's going to be 2 equals, so 3 tan theta minus 5 tan theta is going to give me negative 2 tan theta. Divide both sides by negative 2. I get negative 1 is equal to tan of theta. Now I want to think about my 4 quadrants here. So all students take calculus. We're trying to get out a negative tan, so that means not where it's positive. So we're looking at quadrants 2 and 4. So we can draw our triangles in. And now we want to think about, well, how are we going to get out a negative 1? So remember, tan is really the opposite over the adjacent. So this is really saying negative 1 over 1. So the opposite over the adjacent. So opposite over the adjacent, in this case, the negative 1 would be right here. And then opposite over the adjacent. So notice how my signs switch there depending on, if I'm going right or up, it's always positive, left and down is always negative. So this triangle is our isosceles triangle. So it's the 1, 1, root 2 triangle, the 45, 45, 90. So my reference angle here, if we're looking at in radians, is going to be pi over 4 radians. So that's my reference angle we can label. So now what we need to do is actually figure out, well, where are those angles located? So now that we're in radians, I always want to think about this as this is pi and this is 2 pi, but let's get our common denominator of 4. So this is really the same thing as saying 4 pi over 4. This would be the same thing as saying 8 pi over 4. So pi over 4 in the second quadrant is 1 less pi over 4 than 4 pi over 4. So this is going to actually be 3 pi. So theta will be 3 pi over 4. And then this pi over 4, so down in the fourth quadrant, this is 1 less pi over 4 than 8 pi over 4s. So that means we're looking at 7 pi over 4. So those would be our answers for this one. And that would be in radians. Let's try another one here. So solve algebraically for the exact values over the domain of 0 to 2 pi. Again, not including 2 pi. So same process. So let's bring the 6 over. So we have negative sine theta is equal to 1. Divide both sides by negative 1. So we have sine of theta is equal to negative 1. So now if you think about this, well, this would mean that the opposite over the hypotenuse has to be negative 1, which if you think about our special right triangles, that's not going to get us your opposite over your hypotenuse, and any of these will not equal 1. So this is where we want to think about our unit circle. Anytime you have a value where cosine or sine is equal to 1, negative 1, or 0, it means it's coming from the unit circle. So just keep that in mind. Tangent, when it equals 1, well, that's going to be your isosceles right triangle. So I can draw my unit circle. So think about where sine is equal to negative 1. So that really means where is the y value on your unit circle equal to negative 1? That's going to be this point right here, this point 0, comma, negative 1. This is when sine is equal to negative 1. So what angle is this? Well, this is in radians. This is going to be 3 pi over 2. And there's only one place on this unit circle where sine is going to equal negative 1, or where the y value equals negative 1. So there's only one solution for this one, and it's just 3 pi over 2. There's no real reference angle because this is one of our quadrant angles. So that's it for that one. So that's kind of a unique situation, and that'll be true anytime you see sine or cosine equaling 0, 1, or negative 1. So just some more practice here. So we go to the next page. Now we're looking at degrees again. So from 0 to 360. So again, isolate. So we have 2 equals, so subtract 6 from 4. So we have negative 2 cosine of theta. Divide both sides by negative 2. Negative 1 is equal to cosine theta. And just like I said on the previous problem, anytime cosine or sine is equal to 1, 0, or -1, that's your red flag that you're looking at the unit circle. So think about cosine being -1 means the x value is -1. So where the x value is -1 is at this point right here. So this is our cosine. So this is at, we're in degrees, so this is at 180 degrees this time. So that's it. Theta equals 180 degrees. So these ones are actually a little bit quicker because you don't have to draw out your reference triangles and figure out the angles. There's only one answer for this one. If we look at the next one, so now we're looking at, again, 0 to 360. So we have secant. So we're going to treat it the same way. So I'm going to bring my 3 secant theta over to the other side. So it's 1 minus 3 secant. So that's going to be -2 secant of theta is equal to 4. Divide both sides by -2. I get secant of theta equals -2. What I like to do for the reciprocals here is I like to tie them back into its reciprocal. So instead of saying secant, that's actually the same thing as 1 over cosine. So for me, I think it's easier just to kind of flip this instead of saying secant, saying secant over 1 equals -2 over 1 and thinking of this as the hypotenuse over the adjacent. I like to just kind of flip it and say, well, this is equal to cosine of the reciprocal of this. So -1/2. Since cosine is equal to 1 over secant, or secant is equal to 1 over cosine, if you just kind of flip the numerator and the denominator, that's equal to the reciprocal. So that's a little bit easier, I think, to then just think about cosine again. So now when I go back to my 4 quadrants, I want to think about, okay, well, -1/2, this is going to be a triangle. So I'm looking at where is cosine. So all students take calculus. Where is cosine negative in quadrants 2 and 3? So we're looking here. So I'm going to draw my triangles. And in my triangles here, these should look the same. I'm looking at adjacent over hypotenuse. So adjacent is going to be -1, hypotenuse is 2. And then now I'm looking at, well, this has got to be √3. This is going to be -√3. So this is a 60 degree. We're in degrees, so I'm going to stick with 60 degree reference angle. So my reference angle here was 60 degrees. So now when I think about my reference angle, where's the location of those? So this would be 180 minus 60, so 120. And then 180 plus the 60 is going to get me the other angle, so that's going to be 240. So this really turned into one of the previous problems we did. It just looked very different because we had secant. We just rewrote it as the cosine of the reciprocal. So the next one here, we have cotangent. So we'll start off, we're looking in radians. We're going to start off the same way, isolate the trig function. So in order to isolate this, I'm going to have to first distribute the 2. So I have cotan of theta plus 3 equals 2 cotan of theta plus 2. Now I can get my cotans on one side and my numbers on the other. So I'm going to go ahead, I'm going to bring the 2 over here. So 3 minus 2 gives me 1. And then 2 cotan minus 1 cotan is just going to be 1 cotan. So now I'm looking at cotan of theta equals 1. This is the same thing as tangent of the reciprocal because tangent or 1 over tangent is equal to cotan. So the reciprocal of 1 over 1 is just going to be 1. So this is just going to be 1 is equal to tangent of theta. So now again, you're thinking about your opposite over your adjacent instead of your adjacent over your opposite. It doesn't really matter. You could solve this first one. It's totally up to you. I always just like to get it back to one of our sine, cosine, or tangent. So now I'm thinking about all students take calculus. I'm looking at where it's positive. So where tangent is positive. Cotan is also positive where tangent is positive. So just keep that in mind. It wouldn't change your answer. And this is going to be drawing my triangles because I'm looking at opposite over adjacent being 1. So the opposite and the adjacent is 1. And this bottom quadrant 3 triangle is going to be -1, -1, because when you go left and down, -1, -1. So this is going to be √2, √2. So this is going to be my 45, and I'm in radians, so I'm not going to write 45. I'm going to write pi over 4 as my reference angle. And when I look at my answer here, the first quadrant's already good to go, so that's my first one. Pi is equal to, or theta is equal to pi over 4 radians. And then in order to get this one, well, again, think about this as pi, and this is 2 pi. So when we're talking about pi over 4, well, this is the same thing as saying 4 pi over 4. And this is 8 pi over 4 when you get your common denominator. So this is 1 more pi over 4 past 4 pi over 4. So that's going to be 5 pi over 4. So there's that one. And then lastly, I have this equation where I have 4 raised to the sine theta power is equal to 1/2. So we're, again, trying to get our answer in radians. So think about this for a second. Think about how we solved something like 4 to the x is equal to 1/2, right? So we're using our exponent rules or our exponential function rules that we use, or logs. So what I'm going to do is try to get a common base, because I think that's a little bit easier than applying logs here. So if I can get a common base, which 4 I can rewrite that as 2 squared. And then 1/2 I can rewrite as 2 to the -1. And now that I have my common bases, I'm going to go ahead and use my exponent rules. So I have 2. When you raise something to a power, you multiply. So this is 2 times sine of theta. So this is just going to be 2 sine of theta. This is going to stay. And now that I've applied my exponent rules, and I literally have base 2 to some power equals base 2 to some power, I know that the powers must be equal. So now I can go ahead and say that 2 sine theta must be equal to the exponent on this side, since they have the same base. So this is exactly like what we just did. So now sine of theta is equal to -1/2. And now we go through and we solve it. So now we can draw our picture. Where is sine negative? Well, not here or here, so it's going to be in quadrants 3 and 4. So we can draw our triangles. And we're looking at, I'm going to try to make these look a little bit nicer. We're looking at, in this picture, opposite over hypotenuse. So opposite are going to be our -1. Our hypotenuse will always be positive. Opposite in this picture is going to be our -1. Hypotenuse is 2. So this is going to be -√3. This is going to be +√3. If we're across from the 1, our reference angle is going to be the 30-degree reference angle, or it's going to be pi over 6 in radians. So this is pi over 6, and this is pi over 6. Now we want to think about, how do we get this entire angle? So if this is pi and this is 2 pi, how do I rewrite those with denominators of 6? Well, this would be equivalent to 6 pi over 6. This would be equivalent to 12 pi over 6. So this would be 1 more pi over 6 past 6 pi. So that's going to be 7 pi over 6. And then this one is 1 less. So we went all the way around, 1 less than 12 pi over 6. So that's going to be 11 pi over 6. So 11 pi over 6 radians and 7 pi over 6 radians, and that's it. So use those strategies. Look for your unit circle. Look for using your reference angles or your special right triangles to help you. And go ahead and try the homework problems.